Hello, Dr. Guillemette here, and I am gonna go through the uniform distribution calculator in Excel. So I'm not gonna talk a lot about the uniform distribution conceptually, but I do want to get to the calculator, right? So here we have Aquaman is waiting on the shoreline of Statistica for the perfect crashing wave to go surfing. And when he gets there, the waves are crashing onto the beach every 5.1 seconds. The time from when he arrives at the shoreline until the crashing waves is observed follows a uniform distribution from 0 to 5.1 seconds. Okay, so what this means is that there's an equal probability of a wave hitting the shore between 0 and 5.1 seconds. I don't know if beach waves actually follow this. This is a modification of a problem. And so here we go. All right, so what is the mean? So here I actually have my uniform calculator set up. And so what I did was I put the left end and the right end in. And so this is going to be the starting point, okay? And then this is going to be the ending point. So I put in 0 and then I put in 5.1. For a lot of my calculators, I highlight in yellow the values that need to be entered. And then next to the ones that get calculated, I put in the formula that it is calculating, right? So for the mean, it is simply take C plus D and divide it by 2. It's the average. It is the midpoint of the two ends, okay? So here, if I've got 0 and 5.1, the mean is going to be 2.55. All right? So now, what is the standard deviation? Now, the standard deviation is very similar. It is still going to be C plus D, but we're going to divide it by the square root of 12. And it's always 12. If you actually put this into an integral, the 12 is what comes out of the integral when you look for the standard deviation. But that's the formula. And what I want you to notice is for square root in Excel, it's SQRT. And then in the parentheses is the 12. So that's the formula. And again, don't forget to put the equal sign in front. All right. So we can see that the standard deviation is 1.4722. Now, if it actually asked what the function was, the function is actually 1 divided by C minus D, or D minus C. I'm sorry, this is D minus C. 1 divided by D minus C, and that'll give you the height of the uniform function. And so that can be really nice as well. So the uniform calculator does that. Now, for our Archimedes problem, the probability that the wave will crash onto the beach exactly 4 seconds after the person arrives. Now here is where we're going to go ahead and put in the endpoint values for our uniform distribution. Now it only gives us one endpoint, right? So if I put in 4 and 4, okay, the probability of 4 is 0. And the reason that is because there is no area. There's no width, okay? So if I'm going to go from 4 minus 4, 4 minus 4 is 0. And so because I've got a 0 in the numerator, there is a 0 probability of it happening at exactly 4.0000000 seconds. Now, between 3.99999, right, and 4.00001, you have a little teeny tiny bit of probability for that. But once you go to 4 and 4, there's no probability for that happening. All right. So what is the probability that the wave will crash onto the beach between half a second and 4.3 seconds? Perfect. Okay. So here is half a second and 4.3 seconds. Now, How is it calculating this probability? Well, the probability is really just the area under the curve, right? And the area under the curve is literally a rectangle. And so it's going to be the base times the height. Well, the height is the 1 divided by the d minus c, the 1 divided by d minus c. So here's your d minus c right here, 1 divided by, times, right, the width. And the width is the b minus a. So you have b minus a divided by d minus c. And so that formula right there gives you the area that you're looking at in your normal distribution over here. And so that's a 0.7451. Don't forget, you have over here the little decreased decimal thing. So if you wanted to, you could decrease. Boop. Oh, doesn't want to decrease the decimal. Oh, I have some lag. All right. So if you wanted to decrease it to 4, right? A lot of systems want it to 4 decimal places. You could totally do that. Okay. So there we go. All right. Now, what if you want the probability that it will take longer than 1.5 seconds for the wave to crash after the person arrives? Now, I'm going to put the 1.5 here. Okay, I'm going to leave this one alone. The reason I'm putting the 1.5 here is because this is my A value. And down here, under the between, I have my less than A and my greater than A. So what's the probability that X is going to be greater than A, the 1.5 seconds? And so that's going to be the 0.7059. Okay? Oh, 1.52 seconds. Boop. All right, so there you go. So 0.702, right? Now, how do I get this? Well, this is the complement rule, right? So the area that's less than, right? The area that's less than is going to be that area under the curve, right? So here's my B minus C, right? Because that's the end point. So that's going to be my A minus C. So that's that area. That's the width times my height. And my height is this f of x right here, the d minus c, And so that gives me my area to the left. And by the complement rule, 1 minus that area is going to give me my area to the right. So this formula right here is calculating the area to the left, and then 1 minus is calculating the area to the right. And it's using this left value here as the cutoff. It doesn't matter what this one is. You can make it 5 seconds. It doesn't change these two. You can make it 3 seconds. Doesn't matter. It doesn't change these two. It only changes the between one. All right. Now, this one I thought was really interesting. I saw this in a book. Suppose that the person has already been standing on the shoreline for half a second without waves crashing in. Find the probability that it will take between 2.3 and 2.9 seconds. Now, this is really interesting because it's no longer starting at 0. It's actually starting at half a second. All of the area now, all of the probability is between half a second and 5.1 seconds. Now, I'm going to put my left and right values in, 2.3, 2.9. So here's my 2.3 and 2.9. And so now the probability that it's going to be in between those two is this 0.1304 right here. Okay? This is the sketch of the graph. What I did was I went from 0 and then 2 standard deviations below and 2 standard deviations above. And then I kind of put those guys in to create the sketch. All right, so That's there to create the sketch. And then all of the formulas that I used in the uniform calculator are over here. I would love to see what you all come up with for your own calculators as you make it your own. But this is the calculator that I created for my uniform layout. If this was helpful, if this helps you get through homework and understand the uniform distribution better, that makes me happy.